Alright guys, let's see. Alright guys, hold on. Okay. Alright guys, let's see, I'm trying to get my everything in order, but hold on. Alright, make sure you put your names on the side. Looks like something's not working on my end, but hello guys, hello. Hello. Alright guys, I'm not sure if you can hear me, but if you can hear me, can you please say maybe I can hear you on the Q&A? Usually I can hear myself on the echo of the headphones, but today for some reason I can't hear myself. So it'd be helpful. Alright, hi guys. I'm not entirely sure if you can hear me, but if you can hear me, can you please write, like I can hear you on the Q&A. I'm not entirely sure if you can hear me because usually I can hear myself off the headphones because usually the first input goes to me, and then I can see the audio, then I can adjust as necessary. But right now I don't hear myself, which is kind of weird. But yeah, just write down on the Q&A if you can hear me or not. I'm not entirely sure. So if I don't see anything next 2 minutes, I'll see if we can fix something. Alright guys? Alright? That's gain. Oh, alright, you guys can hear me. Okay, so looks like we can get started. I just can't hear myself. But I guess I don't need to hear myself, so that's perfectly fine, right? Alright, well, there's a couple things I have on agenda today. I'm just turning on, powering on the tablet, and let's get started. So there's a couple things I have on agenda today, and I guess why I put the headphones on, so let me just leave them out. Okay, so there's a couple of things I have on agenda today, right? The first thing is we're gonna just maybe quickly look over the rest of the volume 1 scrambled paragraphs, but today it's not really gonna be scrambled paragraphs today because I feel like the last 2 days were fairly tiring on doing that many scrambled paragraphs and whatnot, right? So today's not really gonna be a scrambled paragraph day. Today's mostly gonna be like an interesting math question day. Got it? So I'm going to give you guys a couple math questions. We're going to work through a couple concepts on the math. We're going to try to get better at them, and then hopefully we'll take it from there. Got it, guys? So for now, if you have any questions on the scrambled paragraph and the remaining scrambled paragraph questions on this exam, you can let me know now. Otherwise, we are going to move on from the scrambled paragraphs. Got it? So if you have any questions on the scrambled paragraphs over here, you can let me know. Other than that, we're going to move on, right? Keep in mind that I am going to be checking your scrambled paragraph handbook volumes tomorrow, so I do expect volume 1 and volume 2 completed, right? If you need to work on another sheet of paper, please bring it on another sheet of paper. Got it, guys? Cool. Alright, looks like we can all hear me. Naima, hi Jonathan, hi Farzana, hi Taifor, hi Ahmed, hi Nisar, hi John, hi Naima, hi Taifor, hi Nisar, hi Javed, hi Opiyami. Alright, looks good. Everything looks good. Alright, keep in mind that today's session will also be markedly shorter. Right, only because I feel like we're gonna go over a lot of stuff in the class tomorrow, and I want to give you guys time to finish over and review all of your books. Got it? Very important that we review all of the books every single day. Now, without any further ado, looks like we have no question on the scrambled paragraphs. I'm just gonna move on. I'm gonna move on, create a new page, and we're gonna go there. I'm gonna zoom in, and we're gonna work on a couple problems, right? So I have a couple problems picked out for you guys. And we're going to start with those, and then we're going to move on. Got it? So, yes, you guys can write in the book if you need to. But for now, we're doing math problems, so take out your little sleeve, maybe a notebook. Those would all be optimal. Alright? First math problem is this. Let's first start by answering these two questions. Got it? Let's start by answering these two questions. Wait, why am I here? Alright, guys, how are you doing on that problem? Okay, Naima says that the first one is 4. Second one is 16. Everyone else should participate. Let's try it out. We know that a product of a number can be found by squaring the difference of that number and 2. So, squaring the difference of that number and 2. So let's say the number is equal to n. That would pretty much be doing n minus 2 squared, right? Just squaring the difference of that number and 2. Okay, so let's take a look. Now you're gonna plug in 4. So 4 minus 2 squared. That's the first one. 4 minus 2 is 2. 2 squared is 4. Second one, well, negative 2. That's going to be negative 2 minus 2 squared. Negative 2 minus 2 is negative 4 squared, so that's 16. Good job, guys. Good job. Moving on. Just going to move over my screen share thing, and then you guys will be able to see something else. It's pretty cool. Lesson number 10. Can I go back? Yeah, sure. Guys, this is a couple questions that we devised in addition to a couple PSAT books. Actually, I'm not gonna go back because that's going to harm the, well, other people won't be able to see the question at hand now. So I'm just going to put it up online later. Number 10, guys. Okay, C versus A. Any other answers? Alright, let's go over it, guys. Alright, r plus 9 is 4 more than s, right? So r plus 9 equals 4 more than s, so s plus 4, right? Then r minus 11 is how much less than s? Well, if you think about it, we're at r plus 9 here, right? Well, to get to r minus 11, well, first we could like subtract 9. We can subtract 9. And we're left with r is equal to s minus 5. Everyone sees that? S minus 5. Now, do we want r? No, we want r minus 11. Well, how do we get to r minus 11? Well, we can subtract 11, and we're left with r minus 11 is equal to s minus 16. Got it? So s minus 16, that's going to be 16 less than s. Got it? It doesn't say how much less than s minus, it doesn't say how much less than s minus s plus 4. It says how much less than s. Got it? So the correct answer is going to be C. Any questions? Alright, moving on. Let's do number 14. Okay, first is B. Wait, X? Oh, I didn't put the thing. It should be this, guys. Alright, guys, let's go over this. This one's interesting. A lot of you are picking B, and that's interesting. I'll tell you why. You guys see how x cubed is equal to y? I agree with you that x to the 6th if you square both sides, because a to the m to the n power is equal to a to the m times n, x cubed to the second power is going to be x to the sixth power, and that's going to equal y squared. I agree with you, and that's, how much greater, but it tells you x to the sixth is how much greater than x cubed. That's pretty much asking you, what's x to the sixth minus x cubed? Everyone sees that? Well, what do you know? X to the sixth is y squared. What's x cubed? X cubed is given. That's minus y. Well, what answers has y squared minus y? Well, if you factor out a y, you're left with y times y minus 1. Everyone sees that, because y times y is y squared. Y times negative 1 is negative y. Any questions, guys? It asks you how much greater than x to the sixth is how much greater than x cubed. Got it? So that's why you have to subtract. It's not just asking you what x to the sixth is. Okay, moving on. That's fine. Let's do 16. Typher, do you still need help? Alright, let's try to do this one. What is the sum of the measured angles? What is the sum of the measure of the marked angles in the figure above? Well, let's try to think about this. Well, if you take a look, do you see this? Do you see that this angle here and this angle are vertical angles, right? So this is equal to this, then this is equal to this, then this is equal to that, right? Now, if you think about it, that, well, this plus this plus this equals 180, because why? Why? Because they add up to the degrees in the triangle, right? Every triangle measures the angles, measure of interior angles adds up to 180 degrees. So that must mean that this plus this plus this adds up to 180 degrees, right? The opposite angles. All right, just give me a second, guys. I have an incoming chat. Okay, so let's take a look. So you know that this angle plus this angle plus this angle must add up to 180. Well, if you take a look, this is an entire circle plus this is plus that's an entire circle, right? Plus that's an entire circle, except for this little crevice, right? That crevice, and that crevice, right? So we're gonna subtract 180 because we know that they add up to 180 degrees because they're opposite angles in the triangle. So 360 plus 360 plus 360 is 1080. 1080 minus 180 is 900. The answer is B. Any questions, guys? Does that make sense? Got it. So keep that in mind, that since the three angles in the triangle add up to 180, the angles opposite them must also add up to 180, and then each one is just going to be three. Well, you can add up the three circles, so 360 plus 360 plus 360, and then you're going to subtract 180 from that because that's what the measures of the triangle add up to. Not so bad. Let's do one more. Let's do not one more, but a few more. Let's do 15. Nope, you guys don't have the book that I'm going over questions from. Okay, ready? Let's go over this. What is 500% of 45% of 22% of n? Well, a couple of things to do here is, first you're going to find 22% of n, right? And that's going to be 0.22n. Then you're going to find 45% of that. Well, how do you find 45%? Well, honestly, I would estimate that to be about almost half. So maybe I'd say like 0.10n, right? And then, because 0.11n would be half, and then I want to find 500% of that. So what's 500% of something? Well, it's about 5 times something. So that's 5 times that, and that's going to be about 0.50n. So which answer choice is closest to that, guys? C. Any questions there, guys? Does that make sense, right? 22% of n is 0.22n, and then you do 45% of that, which is about 0.10n. Then you take 5 times that, because 500% of something is 5 times something. That becomes 1.50n, and 0.495n is the closest. Got it, guys? Moving on. Let's do number 10. Nope, we just went over grammar paragraph volume 1. Okay, ready, guys? In Miss Picker's third grade class, the ratio of boys to girls is 7 to 5. So we know that boys to girls is 7 to 5. If there are 14 boys in the class, well, that's times 2. So how many girls are there? 5 times 2 is 10. Then how many students are in the class? Well, there's 14 boys and 10 girls, and assuming that those are the only genres. So 14 plus 10 is 24. Yeah, Dylan, we pretty much finished volume 1 to the extent I wanted to, but I think we got to like test 16. Let's do number 12. Test 16 of Volume 1. Test 16 out of the 20 tests. Alright guys, let's take a look. The ratio of pens to pencils in Dora's drawer is 3 to 1. So pens to pencils is 3 to 1. The ratio of sharpened pencils to unsharpened pencils in the drawer is 2 to 1. So unsharpened to sharpened is 2 to 1. If there are 18 pens in the drawer, how many pens in the drawers are sharpened? Okay, let's take a look. Now, we have 18 pens in the drawer, so how do we get to 18 from 3? Well, obviously we have to multiply 6, right? 6 times 3 is 18, 6 times 1 is 6. So when we have 18 pens, that must mean that we have 6 pencils. Now we know for a fact that unsharpened plus sharpened is going to add up to the number of pencils. So let's say call this x, and let's say call this x, right? 2x plus 1x must add up to these 6 pencils, right? That's the only thing that makes sense. So 3x is equal to 6. Divide by 3, x must equal 2, right? So if x equals 2, and the number of sharpened is 1x, 1 times 2 is 2. So there's 2 sharpened pencils, and there is 4 unsharpened. Everyone got that? Just taking a minute to look over that. This is quite a bit of work. Alright, let's move on. I might have to leave a little bit earlier today because something at the center, but let's just continue for now. Number 18. Yep. Unsharpened is 4, and sharpened is 2. Yep. Actually, no. We kind of messed up the ratio a little bit. The ratio of sharpened to unsharpened is 2 to 1. So that should be sharpened, and that should be unsharpened. So it's actually the opposite. Sharpened would be 4, and sharpened would be 4, unsharpened would be 2. Be careful with that. Sharpened to unsharpened is 2 to 1. So sharpened to unsharpened is 2 to 1. Guys, take a look. Remember the ratio of sharpened pencils to unsharpened pencils is 2 to 1. So it should be sharpened to unsharpened 2 to 1, right? So we add the x's, then we have 2x plus 1x is equal to 6. 3x equals 6, and then divide by 3, x equals 2, right? 2 times 2 is 4, 2 times 1 is 2. So it's 4 sharpened, 2 unsharpened. That would make it, how many pencils are in the drawer sharpened? That would make it 4, which is B. Alright, let's continue. This is number 18. Yeah, I can go back to the other question. Okay, let's take a look, guys. So 12 is there. Let's try to do 18. We have the ratio of pennies to quarters in Garrett's pocket is 4 to 1. If there are only pennies and quarters in Garrett's pocket, which of the following could be the amount of money in his pocket? Well, let's take a look. If your pennies to quarters ratio is in 4 to 1, that means you must have what? You must have like 4 pennies. If pennies to quarters is in 4 to 1, that means that you pretty much have like 0.04 cents and 25 cents, so 0.25. That's like having $0.29 to be like 29 cents, right? And the idea here is that, well, let's say you had 8 quarters, 8 pennies, and 2 quarters. Let's you double the ratio. What happens? You're going to get a multiple of 29 or 0.29. You're going to get a multiple of that. So which of the following could be the amount of money in his pocket? Well, the idea is that the answer must be a multiple of 0.29. Let's take a look. A lot of people say 18D. Let's take a look. Does 0.29 go into 45? Well, 0.29, let's, I think maybe 5 could go. 5 times 9 is 5. 4, 5 times 2 is 10. $1.45. So there we go. Since 0.29 divides evenly into 1.45, D is an answer. Alright guys, move on. Let's do number 13. Yep, you probably have, so let's get it. Yep, you probably have, so let's get it right this time. Well, it looks like a lot of people are saying D. Let's try it. How many positive integers less than 1,000 are not divisible by 9? Well, how do you attempt these type of problems? Well, you can figure out how many are divisible by 9, and then you can do some subtracting, right? So 9 into 1,000 is 1, 9, 1, 1, 9, 1, 1, 9, 1. So it's like a remainder of 1, right? Interesting. Cool. There's 111 numbers that divide evenly into 1,000. Now, 111 multiples of 9 between 1 and 1,000. Now, let's take a look. It says, how many positive integers less than 1,000 are not divisible by 9? Well, how many positive integers are less than 1,000? Well, that's going to be 1, which is the smallest positive integer, to 999. because that is the largest integer that is less than 1000. So that's 999 numbers minus 111. That's 888. D is correct. Good job, guys. Let's do number 19. Alright, I see a whole slew of other numbers, so let's take a look. Brady is about to pull 4 cards at random from a deck of 10 unique cards and line them up on a table. What is the number of card arrangements that Brady can make? Well, he's going to pull 4 cards at random, right? So let's say 1, 2, 3, and 4, right? Now, it's 10 unique and he's going to line them up on a table, right? Now, when he puts one card on a table, he's not going to take that card back, right? He's going to keep on putting cards on the table. So his first, when he has 0 cards laid down on the table, he has 10 possibilities, right? And then once he puts the first card over here, once he puts that first card in the first, on the table, he only has 9 more left in his hand. There's 9 possibilities. Then once he has put 2 cards down, well, he only has 8 left in his hand, and you guys get the gist. 10 times 9 is 90. 90 times 8 is 720. 720 times 7 is something large. Gonna go with D, 5040. Alright. Good job, guys. Moving on. I want to see you guys do 13. Alright, let's try it. Well, guys, take a look. Do you see how 3x plus 7y is equal to 22, and 2x plus 6y is equal to 22? Alright, now let's take a look. We know that 3x plus 7y is equal to 22, and 2x plus 6y is equal to 12. Right, now there's a couple things that we could do here, right? There's a couple system of equations, a couple ideas that we can definitely, work through here. We want to find 13x plus 13y, right? And obviously there's a couple scenarios that we could do, but let's say we add them, right? We're going to be left with 13y plus 5x. And that's tempting, but is that 13x plus 13y? No, so it's going to be messy. Well, now how about I propose subtracting them? 3x minus 2x is x. 7x minus 6y is y. 22 minus 12 is 10. So x plus y is 10. Well, how do you get 13x plus 13y? Well, if you multiply by 13, and you multiply by 13, and you distribute, that's going to be 13x plus 13y. And 13 times 10 is 130. Got it, guys? Not so bad. Think a little creatively. I want you guys to be able to do number 10 and number 14. People say B or D for the D. I see a lot of D's right now. Let's take a look. A squared is equal to B. What's a to the fourth in terms of B? Well, in terms of B. Okay. Well, there's two ways to think about it, right? You can either square both sides, and you can square that, and a to the fourth is equal to B squared. Boom. Got it, guys? Boom. That's it. You could do a squared is equal to B. You could also multiply by a squared and multiply by a squared. So that'd be a to the fourth. Well, what's a squared? A squared was equal to B, so that'd be B times B, which is B squared. So same answer. 14 is D. How about number 10? Well, let's take a look at number 10. What's x to the 4 times x to the 6? Well, you should know the exponent law that says a to the m times a to the n is equal to a to the m plus n. So let's say you had 2 cubed times 2 squared. That's 2 to the 3 plus 2, which is 2 to the 5th. So over here, x to the 4th times x to the 6th over x to the 8th equals 81. Now, x to the 4 times x to the 6th is x to the 10th divided by x to the 8th power is equal to 81. X to the 10th divided by x to the 8th is x squared. X squared is equal to 81. If x squared is equal to 81, x must equal 9. But we're only looking for x squared, so that's really a. Got it, guys? So 10 is a. Okay, we can do number 10 again. So 10. We know that there's an exponent law that says a to the m times a to the n is equal to a to the m plus n, right? So for example, 2 cubed to the third power times 2 squared to the second power is equal to 2 to the 3 plus 2. 3 plus 2 is 5, so it's 2 to the 5th. Now, we can use the same exponent law over here. X to the 4th times x to the 6th is going to be equal to x to the 10th, because 4 plus 6 is 10. Now we have x to the 10th divided by x to the 8th. Well, a to the m divided by a to the n is equal to a to the m minus n. So just subtract the exponents. Just like you add the exponents when you multiply, you subtract the exponents when you divide. Well, x to the 10th divided by x to the 8th is x to the 10 minus 8. 10 minus 8 is 2. So x squared is equal to 81. Well, if x squared is equal to 81, x must be equal to 9 or negative 9, but it only asks for x squared. So x squared must be 81. Got it? Not so bad. So x to the 4, x to the 6, combines to x to the 10th, divide by x to the 8th, you're left with x squared. X squared is 81. That's really all there is. We're only going to do one more question, and that's going to be number 13. W to the 10th power. Sorry guys about the W to the something. Let me just move it over a little bit. Maybe that'll help. Alright guys, let's do number 13. X to the 6 is equal to 60. Looks like no one has gotten it. How do you get x to the 12th? Well, if x to the 6 equals 60, and you know the exponent law that says a to the m to the nth power is a to the m times n, right? So if you add 3 to the 4th power to the 3rd power, that's equal to 3 to the 12th power, because 4 times 3 is 12. Now, how do you get from x to the 6th to x to the 12th? Well, you can square it, no? Because 6 times 2 is 12. So that's x to the 12. 6 times 2 is 12. Now 60 squared is 3600. So that's that. So that's the first part. Now we're multiplying that times w to the negative 10. You should all know that a to the negative m is equal to 1 over a to the m. So let's say you add 4 to the negative 2. That's equal to 1 over 4 squared, which is 1 over 16. So we have w to the 10th, and when we do w to the negative 10, well, w to the 10th is 20. So w to the negative 10th is going to equal 1 over 20. Got it? So x to the 12th is 3600. So w to the negative 10th is 1 over 20. That's going to be 3600 divided by 20. Zeros cancel out. 2 goes into 36 18 times, and that we're left with 180. Okay, you guys don't understand 13, so let's try to slow down a little bit. Do you guys see how x to the 6 is equal to 60 over here? There's an exponent law that says a to the m to the nth power is equal to a to the m times n. So pretty much when you have something to the something power, you multiply the exponents. So let me give an example of how that works. Let's say at 3 to the 4th power, all to the 3rd power. Well, we would just do 4 times 3 is 12. So 3 to the 4th to the 3rd power is just 3 to the 12th power. Right? Cool. Now, we're given that x to the 6 is equal to 60. But we want x to the 12th. How do we go from x to the 6th? Let me just answer the loan really quickly. No, the loan. A to the m to the nth power is a to the m times n. A to the m times a to the n is equal to a to the m plus a to the n, which is just going to be plus n. Got it? That's the rule. Alright, but quickly, we want x to the 6th is equal to 60. Right? We have x to the 6th is equal to 60. We want x to the 12th. How do you get from x to the 6th to x to the 12th? Well, you can square it. Well, what happens when you square it? Well, 6 times 2 is 12, right? And that's not what happens when you square it. So you want x to the 12th. So to go from x to the 6th to x to the 12th, you would just square it. Well, if you square one side of an equation, you have to square the other side of the equation. So x to the 6th squared is x to the 12th. Square the other side. 60 squared is 3600. So this x to the 12th is equal to 3600. Now let's work with it and involve w to the negative 10. Well, they give us w to the 10, and we know that there's an exponent law over here that says a to the negative m is 1 over a to the m. Well, So 4 to the negative 2 is 1 over 4 squared. So the negative goes away when you do 1 over it. So w to the 10, well, now we want to add a negative, so let's do 1 over it. So w to the 10 is 20, so w to the negative 10 is 1 over 20 over here. Now, we know what? Well, we know that x to the 12th is 3600 over here, and we know that w to the negative 10 is 1 over 20 right next to it. So what's 3600 times 1 over 20? Well, zeros cancel out, and you're left with 2 into 36, which is 18, so 180. Got it, guys? Alright, guys, guess what? That is the last question that we are going to do today. I have to leave early because I'm needed at the center. You guys should continue to finish your blue books, your blue handbooks, and you should continue to review all the work that we did. Review the Barons, review the ARCO, review the McGraw-Hill, and then we're going to continue tomorrow. Right? I'm sorry for the early end time today. Got it, guys? But make sure you keep reviewing the work, right? Make sure you know how to do the entirety of McGraw-Hill questions. Remember, make sure you know how to do the entirety of the ARCO. Make sure you know how to do the entirety of the Barons. Got it, guys? We are gonna end very early today. That's because I have to go. But I'll see you guys tomorrow. Got it, guys? Alright, have a good one. Oh, also, make sure that your diagnostic homeworks are due tomorrow. Right? Your diagnostic homeworks are due tomorrow. So for every question you got wrong in the diagnostic, you have to write me an explanation. Got it, guys? That is due tomorrow. Right? So good luck with that one. Have a good one, guys. Bye.